Okay, so this is problem number 6 from the section 2.6 notes that we didn't get to in class. It asks what values of a and b would make this function differentiable at x equals 3. So we're going to follow the same process we did for problem number 5, where we check for continuity and differentiability. We'll start with continuity. So for continuity, we need to check the limits as x approaches 3 from the left and the right. As x approaches 3 from the left, that's going to use the top piece of the function. And my iPad is being a little wonky today, so bear with me. And when I do that substitution, that would give me 9 minus 3a plus 2. And it's 11 minus 3a. And I need to take the limit from the left. Sorry, from the right. I just did it from the left. The limit from the right would use the bottom piece of the function. And again, I would do a substitution. I plug in 3 for my x. That's going to give me 3 plus b. And I would need to consider f of 3. That uses the bottom piece. So I'm just going to go ahead and write that equals f of 3 here. Now, in order for this to be continuous, those two things have to be equal to each other. The limit from the left, the limit from the right, and f of 3. So I'm going to set 11 minus 3a equal to 3 plus b. Now, that's not enough to tell me what a or b are right now. So I'm going to turn and look at my differentiability relationship. Now again, my limit as x approaches 3 from the left of my derivative, which would be 2x, and remember a is a constant, so the derivative of negative ax would be minus a. When I do the limit as x approaches 3 there, that's going to give me 6 minus a. That would have to equal, if this is going to be differentiable, and we're told that it is, would have to equal the limit as x approaches 3 from the right of the derivative of the bottom piece. Well, the derivative of x plus b, derivative of x is 1. The derivative of b, which is a constant, is 0. So this limit would be 1. So if this is going to be differentiable, and again, we're told that it is, or we want it to be, 6 minus a would have to equal 1. This is enough to solve for a. So a is 5. And now that we know that a is 5, we can use that to find what b is. Wow, this is really, really wonky today. So b is negative 7. And that's how you solve this for a and b.